Hello to everyone. My name is Greg. I'm a technical person, so this is not natural way to meet present on the stage. So I'm mostly a little shiny. This presentation will be a little more technical. Please raise the hand who already training the model. So for example, SFT. Who done SFT previously? Okay, few people. Who done the reinforcement learning training? 1, 2 people, 3. Okay. So first of all, I'm from the company Genomic. I'm the founder. What we are doing, we're using the AI and we have own big AI cluster to design new medicines, especially antibodies, monoclonal antibodies, fully in silico that we're designing and during last 5 years. And we also have own laboratory when we're producing them as the potential medicine and validate in the laboratory that it works. 100-hour antibodies already is validated on the patient's data in National Institute of Oncology. So the key and my biggest dream, one of the most important dream, is to how to use our technology and our brains to solve important problem. And I believe that one of them is inside the monoclonal antibody. But I started design and train deep neural networks from 2019, starting from transformers, from BERT, from XLNet, some beginning of everything before GTP2. And now we have 32 H100. So the first H100 GPUs was in Poland was bought by us. We are the NVIDIA partner, and we have more than 150 4019, 5019 that we build ourselves to decrease the cost. Because now we have around 200 GPUs and own cluster, own data center that we build as cheap as we can. But with infinite band, so we can use this 32 H100 to train one deep neural network of all of them in the same time. On the electricity, we spend more than 1 million PLN. And I'm the technical person, so I'm working a lot of the code and training the networks. This is my daily job. And mostly I'm focusing on the diffusion models and transformer models. Transformers means not only the static transformers with quadratic attention, but also how to use, for example, state space models. Do you know state space models, SSMs? Mamba, Samba. No, so this is the different alternative, how to speed up the transformers for long context. This is very crucial, for example, for agentic AI, because this gives us the much bigger context and work with that much faster. And during the last 5 years, we already tested on our GitLab, have more than 500 replications of different papers. And I think that weekly I'm reading around 100 papers. My first mission is to try to solve oncology problems using the deep learning by designing the antibodies and validating them. And the second, on the same time that I trying to do, is how to challenge the abstract reasoning corpus. Are you familiar with the Keras framework? So François Cholet created the great paper, how to solve the intelligence, the nature of intelligence. And this is the second part. This is not published yet. This is my biggest mistake, but its task pilot soon will be visible as the general agent. And in this conversation, I will speak about the most important part of what we need to do to train deep neural network. And the essential part of that is the reward model. So how we teach the deep neural network, what should predict and what should not, how to implement the gradient flow to the pipeline to have some gentle changes that will do not change this network. I will little modify this speech to try to say to everyone. So to try to explain everything as simple as it can. I understand. I know that everyone will understand that, but it's the crucial if you want to train the models. So as you know, we have SFT. Yes. If you done already SFT, you done that the last time. SFT have the biggest problem because SFT changed the model so strong that the model forgot the past knowledge. And because of that, every people around the world working how to train the model, but train it more gently. So what is the difference? In standard SFT, when you have the tokens that model want to predict, this is the standard distribution of these tokens. And what you try to do is you try to fix the model and say him, please predict exactly these tokens step by step because this is my rule, this is my data set. And you can imagine like the second person in the school will tell you that you must use exactly this word to explain some topic. So you learn, in Polish I will say, na pamięć. So it means that you're learning every single word in this sentence. This is very bad because you do not generalize the knowledge from that information. You only remember everything, every token. You know how hard is that. And for models, the same. But models are forced to learn that. And because of that, this distribution of these tokens, it's completely different what this model will predict. Sometimes simple word will change, simple tokens. And these have a huge impact for internal representation for the model, because this few changes inside the same text written in other words change completely the distribution. And this is why these models do not generalize. I'm working a lot for the last 5 years about the grokking. The grokking is the holy grail of the world deep learning. This is the moment when models start to generalize in all answer magically after a long time of training. And everyone now, Grok, this is why Grok is Grok from the Elon, working the same. My friend just left the team because they're focusing mostly how to learn the model to grokking. And the other alternative that came to the market just 2 months ago was the same that we have in the intuition longer, is the self-distributed fine-tuning, of course. Sorry, I know that, but this is stress. And what are we doing? We're generating the next tokens by the model. So model explaining the same by our word. So changing the distribution only a little bit, using the same tokens to predict. And this have a huge impact for the learning, because on this way, we have the same results for the SFT, but all other tasks still working. Model do not still remember all other things because the distribution of what we're learning is the same that we have in our words. And going with that deeper, so the standard for tuning is of policy, I'm sorry. So it's changing the distribution of the tokens so strong that is the key of the catastrophic forgets. And when I start training the models in 2019, when we teach the model how to everything, but we validate in very crazy questions. For example, how to create the meal with the cat, how to make the bomb. So the questions that are out of the data set to be sure that nobody asked this question previously. So it's as crazy question was as better for us to judge. And this catastrophic forget, this is the biggest problem that I had during the last few years. And SFDT keeps training policy and making generalize much faster and much denser. And because of that we're teaching every token, so the KL divergence is the same or very similar, is much lower. And because of that, the generalization is 10 times better using a very simple modification. And the teacher that generate those tokens is the same model. So this is the situation when you must repeat after the teacher, and you learn from repeating what teacher said, not directly for the word that you heard. So because of that, many our teachers ask us, please repeat. And this repetition teach us directly. And this enable the most important problem with deep learning. So this is the continual learning. So we can teach more and more to the model without forgetting. And this distribution is crucial that the base policy, so what model want to answer, is very much closer than what we have in the SFT data. And what is KL divergence? Are you familiar with that? No. So KL divergence is the difference between two probabilities of the distribution, between what model won't answer as the student and what model should answer from our data on from the teacher. And this KL divergence, that is very strong part of the GRPO, it's a very crucial part of the calculating the probability of what model will learn in the future learning. And this technique give you, for example, if you compare SDTFT to SFT, it's in the standard situation. I had that many times. You train on the tool use, then on the science, then on the medical, and he forgot the past knowledge. And using this technique, when model repeat, the distribution is slower. You have this situation. I proved that the same. This is the screen from the paper. I done that the same for 6 months ago in the very similar way. And trust me, it's working. You can do that tomorrow in your lab. And the second part of that, because we are here not to work about SFT. We are here to work with the reinforcement learning. Reinforcement learning is usually the second stage of the teaching the model. So mostly reinforcement learning, we are not sure in the community, but probably the reinforcement learning do not teach the new knowledge, but mostly sharp the thing how we get the data from the model. And we can use the same technique as the self-distillation policy optimization. So, as you know, GRPO, who used the GRPO previously? One person, okay, 2, 3. So GRPO was published 1 year ago as a part of the DeepSeek. So for innovation, this is one of the four very important innovation. One was MLA, a few different. But the GRP, what you're talking to the model, that this is binary. So true or false, your answer. So GRP doing that. Model, this is a question, please generate your answer. And model generate the answer 20 times. And we judge which answer are good or bad, and we tell the model, this answer are good, this answer are bad. And because of that, this is very expensive to sample the model so often that we need a lot of runs on SGLang or VLLM to sample a lot from the model. So we use the same technique to use the rich feedback to the model about every single token to force the model, not this answer is wrong, but this is the right distribution for these tokens, but generated by the student alone. So the student model generate what should be the good answer for this question that is very close to the answer because he know the answer during the generation to have better divergence between those two representations. This is so natural for me and for non-technical people when I'm explaining to them, because this unblocking the huge possibilities inside the whole LLMs. So the model becomes own teacher, reads the answer that you have in data set and read back and learn from those information. This is very crucial because this distribution is similar, but it's much closer. Of course, this model do not learn directly this answer, but in your training pipelines, you probably have curriculum learning. So I start training models like starting with simple words like children, saying try to teach them the basics and step by step going inside. If you do not use curriculum, this technique will also do not work. And in this feedback is extremely important. You do not need to pay to any more expensive, better model because it's not necessary in this technique. I have only 12 slides. I think that I need only 7 minutes, but no, I will have 30 minutes talk. So in this technique, what is critical that you can beat cloud code on coding is not a joke, only because the distribution is better and models still remember. And for example, this work in this situation, when we have the question, model try to answer, for example, from environment, from Harbor, from Jacek, I have the same, but using the virtual machines on the Firecracker. But the model see the answer from the environment, see the answer only what is wrong, and try to reshape the answer using this knowledge. And this reshaping, this answer, comes from the same model that we're teaching. So the distribution is much better. And because of that, for example, this is the reasons I have similar or more better probably. This is from paper so for example, this is the cloud code results. The dot line. You have much better on the live code bench than the newest one, only in this simple technique. Not simple, I spent many years to develop things like that. But at the end of the day, this is the small amount of, this is only 10,000 lines of code. And this is very important, that the biggest bottleneck in the GRPO is thinking. What you see in the open source model about the long thinking is not a feature, is a bug. People thinking this is a feature because QVQ or any other stupid model answering with the long tokens because GRPO have a bug. In the new way, like Cloud Code, they do not have those bugs. They have instant answer almost. Very small thinking, only what is necessary. Why? Because model is the reward do not comes from the how long he responses. And this change a lot. Also, how fast we can, how small amount of data we need to train the model. The work clock time is much slower because we do not sample as much on this technique. And and I also modify and second. I will back to the MaxiRel. This is our version as DPO plus for that. So we extended that in that the feedback is not only the text, but the feedback is a lot of different validation. So our student checking the whole list of things, what to check if do not make any mistakes. So I'm working with the models directly like students, like teachers working with the students in the school, giving him a list what to check. So students generate the answer. We have the evaluator. So it is the same model like the student on the same pipeline, but different prompt, checking a course. We have 12 different scores, different prompts to check the scores and they generate the checklist. And teacher generate the response to the model. So why I done that in the 3 stages? Because I expand the representation to much bigger to decompress that information. And because of decompression, it's much easier to align this model in gently way in the good direction. And of course, each criterion that we're checking is 0, 1, but the model changing the response as the criterion list. And this evaluator have the huge list to check. Teacher applying to this model. This is the same model that we're teaching. So only different prompts, only this and the sampling, and we generate the distribution that is much higher, much closer. And is what is very, very important, that is very gently sending the very rich signal, because signal is not only 0, 1, but all token distribution. So we have much denser information to the model where he made the mistake. And before the Prism, so our golden egg, there is the MaxiRel, also the new one from this month, I think, so from the January, that only optimize approximation of the fixes and work much faster. This comes from, I think, that 2 weeks ago that was published in our benchmark. We're also using that on the production now. So on the test time scaling is more efficient because the rollout are much higher, much closer to the GRPO. But what do you know now from the market, that the cost of the training is huge? Of course, was, still is. But if you will generate the pipeline in the right way and test different methods, you can speed up the training sometimes 10,000 times, 10 times or more in the open source models, getting very good results. In the current stage, we scale almost to max most of the benchmarks that are. And a second. And the last is the Prism. This is our reward model that we have as the crucial part of our pipeline, how to gently teach the model to try to create the AGI. Of course, AGI is impossible now. We don't have the thinking like in typical way, but we want to teach the model doing the simple stuff, more advanced, and the planning. So we try to teach the model how to create the loops, how to create the plans, to avoid an agentic framework. Agentic framework, from my perspective, is already the past. So there will be no necessary for that. If we know how to plan, model can plan any stages and what to do step by step. And what is this Prism? This Prism is the real-time training all the time during inference that I try to do during my work. So I working with the model that is all the time training when I'm doing this stuff. When I'm putting something to the cloud code, this is recorded, but I will force to do not publish to the YouTube. We can see exactly on the background, checking on the man in the middle, what we're sending to the cloud code and generating a data in the real time for our model to decompose this problem to lower problems that model can already respond and teach the model all the time during the inference. And we have multiple reward signals. This is very important because we need to be sure answer of the model never should be perfect. But imagine our teachers, they checking if we answer right in the general, not if we use right word. The key was to only mark that this in general is okay, and this is much better than forcing. Of course, we can penalty the length of the response, but it's working. And you can use SDFT, DPO. If you are open, we can share with you those our reward models in our pipeline. And what is the key takeaway? Binary rewards, not even enough. Richer signal, faster learning. So this is why this is most critical part. You're teaching the model about every single token. The second is on policy training. This means that model should use own words because it's much closer to their representation, not what you get from the Hugging Face dataset. This is the worst scenario, especially in SFT. Model as its own teacher, as we speak previously. Token level credit assign. So what is very critical, you try to learn model only where it changes. This is more sophisticated. We don't have time for that. But also in every single token about what the good results. Yeah, so many different results, like pluggable results, and you can connect many of them in the one pipeline. So, we have some nice loop here. I don't know, it's not playing, sorry. But at the end of the day, this is enough for you to close the loop of the training. And one more thing that I want to add, that if you have, for example, this is the crazy. I'm working with the diffusion models for a long time, and now, for example, if you have the Quen 8 billion parameters, in standard way, you have 38 tokens per second on the 5090, for example. In this technique, without any loss, you have 400 tokens per second in one model. What is that? This is the huge innovation. I previously working with the Eagle. So Eagle is the third part. This is the speculative decoding. What is that? We have the small model before main model that we teach the same data or the answer of the general model, and this small diffusion model is successful in the 80% of the tokens. And the main model receive 16 of that tokens. And if, for example, 5 of them is right, they predict the fifth or sixth and decrease the cost of the calculation dramatically. And this is why this is lossless conversation. Soon everyone will use that as the small diffusion model that you train as the other additional model before your main model. And I trained already 10 of the models like that and have much better results that they have. They receive 400 tokens per second on Quen 8 billion. I receive up to 1,000 per one user. So my goal is to have in one H100 more than 25,000 tokens for all the users. And it's possible to do. I'm working a lot with the diffusion models. But the diffusion is much harder for me to sample in many users in the same time from few reasons. So my results in diffusion are much worse. I use with the diffusion for the proteins. But you can use that. The name of that is the DeFlash. It's crazy good. It's crazy good. I don't know what happened here. Oh, So DeFlash, you can find under the Google. This is the speculative decoding against Eagle 3. Who use Eagle? You used that previously. So this is the way how to speed up the sampling, because the biggest cost is how to have the cheap tokens from our model after that, because our models should work all the time. I now use 7 cloud codes for the biggest package of 200 USD, and soon probably I will lose access to that because Anthropic will limit that. But in the end of the day, the cost of the intelligence, everyone will need intelligence. We need the intelligence. This is very simple intelligence still, but how to get that cheaper is how to get our own GPUs or how to speed up the sampling process from the GPUs that we already have. Exactly. So thank you for the time that you survived with me. If I can answer any questions, please.
Thank you. Thanks. I'm curious. So you mentioned that you use LLM as its own judge. So how do you overcome reward hacking then?
Because the LLM we're judging is not the teacher. So have different prompt. The reward hackings come to the situation that you do not checking what is the side of response, but you only mark it's okay. And this evaluator that we have checking exactly all the responses, all the thickings, and marking that everything is okay.
So you check the reasoning process and
Everything,
Okay.
the whole response. And this is the part of this evaluator. This is the crucial part because there's no reward hacking at all.
I have a question. I've been reading from Onslaught that they've been optimizing the flow by reusing chunks of memory for both the teacher and the learning model. So how much of the memory can you reuse while teaching for both of those parts? Because you've mentioned just that it has different prompts.
I experimented a lot with the cache, but you cannot cache that because it's different prompt in the top. But I mostly learning the LoRa and Dora and merging. Mostly Dora, not LoRa. This is the adapters, as you know. And I'm merging this in the main model because from my results, this is giving the same result. And it's much cheaper, much faster.
Yeah.
And it's avoid this problem that you mentioned.
Yeah. Okay.
I'm curious.
Hi.
You know way more about how to fine-tune and train models than me. What is the current state of research on continuous learning? How to, what are the approaches that you think might work when the model can learn on test time, like based on the real usage? Like
Who knows Sakana?
the memories are kind of a hack to it, so you can.
You know Sakana? You know Sakana from Japan? This is the research organization that they're working a lot from the test time compute. Do you know the Alpha Evolve from DeepMind? So Google DeepMind created a way how to evolve the programs. So now we know that LLMs can generate any programs much better than people, especially Triton, kernels, everything. There's no programming at all. Programming will be the managing. The models will be still, but not in this stage. And to answer your questions, there is a test time compute. What does this mean? This means that we teaching the model during the specific task what work and what work not, using reinforcement learning, for example, on Dora and LoRa adapters. And this gives you the possibility that in this specific topic, the model is much better. So answering your question, what is the current state of the art or the current situation of the research? I think that everyone working with that, I also. So the key for me is I have 1 million records of the own data sets, gold, but soon I will have 10 million or more. And I need to be sure that the model do not forget all other responses. From two reasons: to have this intelligence because it's necessary for me because I'm building automated laboratory that fully in the closed loop doing the whole research that we need in the world. Of course. Yeah, of course. But this is important because, and then, so the friend asking if the model can learn for the user. I already trying to.
Data set is like there is less data to train on.
From my imagination, we will have the LoRa adapters of every single user and swap them on the time, of have the mixture of experts of them. Why? Because this giving is the situation that he will remember every knowledge that I already done. There's a lot of publication how to create the adapters, in which part of embedding the NLP to insert the knowledge against the rack. Rack also will be, from my perspective, closed. Yeah, we already have the agentic rack. It's all fully solved. But at the end of the day, this knowledge should be inside the matrices.
Thank you very much, Greg.